Hi everyone, it's my honor today to introduce you one of the Ray open source software by the open infrastructures community, ZUUL CI, and how it will help you to boost to increase the productivity of your projects. Now let's start it. So let me introduce a little bit about myself. My name is Trinh. I am the Cloud Solution Architect and Product Manager of the FPT Korea. I also the community organizer of the Open Viet, Open Infra, and Viet Open MEC community. Over the last four development cycle of the OpenStack, I am the project team lead for OpenStack satellite projects. You can find me in using this email address or with this Twitter handle. So let's start it. I will go through the this content today. So I will define about CICD and what is ZUUL and what are current issues that we have right now with our CI and what ZUUL can help and what we can do in the future to increase our productivity, our project productivity. So what is CICD? As you can see here, it's the process of automating all of these steps, like from building the code, doing unit tests, deploy to stages, and also release your time from painful process of checking and testing and deployment. Everything will be automatically executed. Yeah, so pretty cool, huh? But this is not a new thing. It's has been CI/CD has been around for a couple of years, like 5 or 6 years, and we can summarize this kind of best practices with us when you're doing the CI/CD. So the first thing is be agile. Be agile as much as you can. Minimize the dependency, making the process as fast as you can. Refactor your projects, refactor your pipeline, so it can be scale in the future. And also very important thing is you have to educate everyone, so everyone have to understand what a CI/CD mean and how it works and how many people on the same team or different team can go together with the CI/CD pipeline, etc. So what is ZUUL? ZUUL configuration is organized around the concept of a pipeline. In ZUUL, a pipeline comprises of a workflow process that can be applied to one or more projects. For instance, these are the three most common pipeline in the ZUUL projects. A check pipeline to display all the checks, all the tests that a proposed chain have to pass before it's moving forward to deploy. A gate pipeline we might implement project gating to automate merging changes to other projects only if their test pass. A post pipeline might update publish documentation for projects when change is made. Yeah, so these are the characteristics of the ZUUL CI. So it implement the gating on Git branches. It has the speculative testing, scaling, pipelines, multi-repository, parallel testing, in-repository job configuration, pre-merge job loading, multi-node job support. And you can also use Ansible for your CI. Yeah, pretty cool, huh? Basically, these are the component of ZUUL. So we have the web interface, we have the ZUUL scheduler to coordinate on the tasks, and executor to execute on the pipeline, and also the notebook to manage the compute resources for the test, for the gating, project gating. Like here, ZUUL can be using with any code review system like GitHub or even Gerrit. June scheduler receive event from remote CRI system and schedule the execution of job according to the project configuration, then report job result to the CI system. June executor use Ansible, like Ansible, pretty cool, to execute job remotely on test node provided by Notebook. Notebook launches, like I said, Notebook manage the compute resources to actually running the test, the integration test, the unit test, and merging, provision, and ultimately destroy nodes needed to run test job, and finally the web interface for you to see the progress of the running job. As you can see here is the sample process of June pipeline from checking and project gating. So this is what we are doing right now with our CICD. Now normally someone open a pull request and it's trigger Jenkins to build and test, and then Jenkins will update back the pull request status, and if everything is good, someone have to go in and merge the PR manually, and then if it's good, if it's good enough, someone have to execute Jenkins job to deploy the new code manually. And as you know, manual works will prone to errors. Sometimes when you accidentally merge some bad PR, and you break the whole system. Who knows? So and the next issue is because, for example, some CI system like Jenkins can only execute a limited number of job at the same time. So sometimes I have to wait for like so long for my changes to deploy or to test to production. Like sometimes I feel like I have to wait for Jenkins to finish the reverse for job like forever. It's kind of exhausting process. So June introduced the concept of project gating. What's the project gating? It is the process of gating at prevent changes that introduce regression from being merged. What's that mean? So let's say develop A, developer B, developer C. We have changes, at the same time, many pull requests at the same time, and some changes from developer A be merged but first, and it may break what the developer B changes. So this project gating will coordinate and to make sure all of the pull requests or changes working before we release it into production. So June keep the main line of development open and working with all developers, and only when a change is confirmed to work without disruption, it is merged. And the thing is, the cool thing is, June do it, help you to automate this process. June gating testing in parallel. So it's executing the test simultaneously. For example, if the review approves 5 changes in rapid regression A, B, C, D, E, like 5 changes. Let's see, in this order: A, B, C, D, E. Job for A, merge chain A, then test. Job for B, merge chain A and B, then test. Job for C, it will merge chain A, B, and C, and then test. Job for D, merge chain A, B, C, and D, and test. Job for E, merge chain A, B, C, D, and E, and then test. When a later job comes, the reverse job have to be tested before it can run. But the thing is, June trigger the test. A will only test A and ignore B, C, D. To test A. The job for E would include the whole dependency chain, A, B, C, D, and E. The job for E will be tested assuming A, B, C, and D pass it. So it doesn't have to wait for the test of A, B, C, and D changes finished. It can run immediately. If chain A and B pass test string and C, D, and E fail, for example, like this scenario, ZUUL will merge chain A followed by B and leaving the failed test there, doesn't matter. And since D depend on the C, it's not like whether D failure is the zone of defect in D or C. So if C fails, you will report its failure and drop C from the queue, keeping D and E. So if C, it will drop C. I mean, if C, D, and E fail, it will drop C and keeping D and E. Next, it will do the same again. So it will start the process again, testing D again at the tip of the branch, and E again D. Is executed. So the chain developer who working on the C, we have to go back and merge fix the error and before it can be merged into the master. So pretty cool, huh? So many changes can be tested in parallel, without having to wait like in Jenkins. And another cool feature of ZUUL is you can test your changes cross with other projects, like you're working on some library B which you're using by library A, so both the changes can be testing against A. So dependency, you only have to do this in your commit message, depends on the pull request, and the change will be tested automatically against all of the dependency. This is awesome. The dependent pipeline. So when ZUUL sees changes with cross projects dependency, it serializes them in user manner when queuing them into a pipeline. This means that if chain A depends on B, and when they are added to the dependent pipeline, B will appear first and A will follow. If tests for B fail, both B and A will be removed from the pipeline, and it will not be possible for A to merge until B does. Pretty cool, huh? So it makes sure ZUUL makes sure every dependent, everything of the dependent pipeline pass before it merge. Chains that land into the independent pipeline are tested independently from each other, meaning that the tests are not sharing a common workspace during testing. This is to indicate that the rate changes are only there to establish dependency. If you it's amazing. Even though it's depend on each other, but each chain will test simultaneously, and then coordinate and then coordinate to make sure that the whole, like A and B, will be merged into the master without any problem. So with ZUUL, what I can think of now is to the possibility and now is to automate everything. This is the dream of every dev, of every system architect, engineer. We're doing everything automatically, so we save lots of time. So we only have to focus on making the RAID software, the RAID system. So so that's it. Here is some of the cool link that you can refer to. I send the presentation slide to the organizer, so you can use it. And if you have any question, just let me know. I have my address here. I used to be, and I am an open source contributor, so I'm willing to help. So if you have any question, if you have any concern or any needs any guidance to use the ZUUL CI for your projects or your company, let me know. I'm willing to help. And it's great to share you my passion for open source. Hope to we have great years ahead. 2021, when the COVID-19 is over and we can meet offline instead of via the video like this. Yeah. So bye. Thank you.